Hello, geometry class. I miss you so much. I hope you are all going to send me an email to let me know your email address and so I can communicate with you. You should be doing your homeworks. And today I've got section 12.5 and I'm going to be doing select homework problems. Now, this section, you may look at it and panic, but don't. Any of you that like doing any kind of puzzles, this is for you. Trigonometric identities are basically just taking something that looks complicated and turning it into something that says this side is equal to this side. So all you do is manipulate each side until they equal each other. How do you do that? Well, you substitute in these trigonometric identities. So if it says cosecant, you would change it to 1 over the sine. If it says the secant, you would change it to 1 over the cosine. If it says tangent, you would change it to the sine over the cosine. If it says cotangent, you would change it to cosine over the sine. And then there's the great trigonometric identity called the Pythagorean identity. It's the sine squared plus the cosine squared of any angle. It could be 10 degrees. Sine squared of 10 degrees plus cosine squared of 10 degrees always equals 1. And in your book and on those videos it explains why. You can move this around. I can subtract a sine from both sides and get 1 minus sine squared equals cosine squared. I can subtract a cosine squared and get 1 minus cosine squared equals sine squared. So all you're doing is manipulating each side until they're equal. So let's take a look at 4 examples from your homework. Number 10, cotangent of x equals cosine over the sine. You want to prove that those are equal. Well, that one's fairly easy because we know the cotangent is the cosine over the sine. So you just change cotangent into cosine x over sine x. And I just put a check mark to show that I proved it. There it is. Cosine x equals sine x. That was a nice easy one. Now let's look at number 14. This looks a little more complicated. You should always first approach these. There'll be more difficult ones later, next year and the year after, but you should always approach these with first changing them into their basic trigonometric functions. So cosecant change into 1 over the sine of x times tangent is the sine of x over the cosine of x. And the secant is 1 over the cosine of x. Well, according to the principles of multiplication, you can cancel what's on the top and bottom of a multiplication, and you end up with 1 over the cosine of x equals 1 over the cosine of x. Isn't this fun? I love doing this. I'm a puzzle person. All right, let's take a look at this. This is looking a little more scary. Well, the cosecant is 1 over the sine of x times the cosine squared of x plus the sine of x equals 1 over the sine of x. Well, when you're dealing with a fraction, this is cosine squared over sine, get common denominators. My common denominator, since this is basically over a 1, would be the sine of x. I don't have to change this term at all. That's going to be cosine squared of x over sine of x plus, well, if I multiply top and bottom of this by sine, I get sine squared of x over sine of x equals 1 over the sine of x. Well, if we write it as one single fraction, we get cosine squared of x plus sine squared of x over the sine of x equals 1 over the sine of x. Well, guess what? Sine squared plus cosine squared equals 1. And according to the commutative property, cosine squared plus sine squared equals 1. So basically, we have 1 over the sine of x, I should have given myself more room, equals 1 over the sine of x, and I'm done. See how this works? I know I'm going quickly, but you can always pause and go back and listen to me again if you can stand it. All right, let's look at 28. This looks a little more complicated, but let's do the same thing. 1 over the sine of x minus cosine of x times Well, don't forget cotangent is cosine x over sine of x equals the sine of x. Well, this already has a common denominator, so we can rewrite this as 1 minus cosine times cosine is cosine squared of x over sine of x. Well, what's 1 minus cosine squared? Well, if we look over there at our Pythagorean identity, 1 minus cosine squared is the sine squared. So we can change this into the sine squared and now we can just cancel. A sine on the top, a sine on the bottom will leave us with sine of x equals sine of x. And we are done.